I'm Zane, and I'm lost in the woods. But luckily, you're all here with me for the 2020 Beast Virtual STEM Camp. I have hiked all the wild places of the world. The highest mountains. The thickest jungles. The widest deserts. And the wettest oceans. But now, I am lost. Wow, I am hopelessly lost. I'm never gonna find my way back home. But luckily for me, I have my beast backpack full of MacGyver supplies. Well, let's see what I got. Well, what do you know? Forgot my compass today. I really need a compass, but I guess I'll just have to make one myself. Now, I think compasses work with magnetism. Let me read up once on how that works. A compass is a tool that uses the Earth's magnetic field to indicate direction. We'll learn more about that later. Wow, fascinating. I'll introduce you to the world of magnetism so we can make our own compass. First, we need to learn about magnets. We've all seen magnets. Perhaps you have some on your refrigerator at home. Perhaps the screwdriver in your junk drawer has a magnetic tip to help it stick to screws. Perhaps you have a computer at home, in which case there's a magnet inside the hard drive. We know that magnets can stick to each other as well as some metal things, but how does this work? First, we have to understand something about atoms. Atoms are tiny particles that make up everything. Atoms are incredibly tiny, but they are made up of even tinier particles called subatomic particles. One of these subatomic particles is called an electron. Electrons spin around the center of the atom, and they are always moving. Protons are found in the center of the atom, along with neutrons. There is an important property of these particles known as charge. Electrons have a negative charge, and protons have a positive charge. Neutrons do not have charge. Back in 1820, a smart Dutch scientist named Hans Christian Ørsted found that moving charges create magnetic fields. Magnetic fields are invisible, but they create forces which can act on other objects. A force is simply a push or a pull. See, this magnet is pulling this paper clip. It is creating a force. To learn more about forces, make sure to watch our pullback car video. Since a moving charge can create a magnetic field and atoms have electrons moving around inside them, each atom is like a teeny tiny magnet. And these teeny tiny magnets have direction. One end is the North Pole and the other end is the South Pole. Since everything is made of atoms, why isn't everything magnetic? Well, in most materials, all of the atoms are pointing in different directions, so their teeny tiny magnetic fields all cancel each other out. In some materials, the teeny tiny magnets are able to all line up in the same direction, and this makes the whole material magnetic. This larger magnet also has a North Pole and a South Pole. Opposites attract. The north pole of one magnet is attracted to the south pole of another magnet, like this. But the same poles of two magnets, such as north and north, repel. Permanent magnets, such as your refrigerator magnets, always have their atoms lined up. In temporary magnets, such as this paper clip, the atoms only line up when they are in presence of another magnetic field. So right now, when I add this permanent magnet, it turns the paper clip into a temporary magnet. First, we need to gather all of our materials. This includes a leaf, a sewing needle, a permanent magnet, and a plastic dish to fill with water. First, we need to fill our plastic dish. Then, we will float the leaf on the water. Like that. Now, we will take our permanent magnet and our needle and rub the permanent magnet down the needle. Make sure to keep doing it the same direction every time. Do this for about a minute. Now, our needle has become a temporary magnet, and we can float it on water so it can move freely and point in the direction of whatever magnetic field it is in. Let's try that now. Now, when I move this magnet near the needle, it points in the direction of the magnet's magnetic field. Now, the center of the Earth is made of iron, and the outer portion of the core is liquid iron that spins and makes the Earth into a giant magnet. And that's why Earth has a North Pole and a South Pole. Compared to closer magnets, the Earth's magnetic field is weak because the core is very, very, very far away. But when we take those magnets away, the compass can line up with the Earth's magnetic field and point north. Oh, what's this? Oh, it's my compass. I had it the whole time. Well, let's see how it works compared to the compass we made. Look at that. They're both pointing north. Nice. Now that I have a compass, I can find which way is north, and I can find my way home. Since this way is north, and I know my house is east of here, I should walk in this direction. Hey, there it is. That's my house. Thanks to the laws of magnetism, I found my way home. Wow, I sure am glad to be back inside. So now, let's recap what we learned. All the stuff around us is made of atoms. Atoms are made of tiny particles such as electrons, protons, and neutrons. Electrons spin around the center of the atom. An important property of these particles is charge. Moving charges, such as electrons, create magnetic fields. In magnetic materials, The atoms line up so their magnetic fields point in the same direction. Magnets have a north pole and a south pole. The north pole of one magnet is attracted to the south pole of another magnet, and the Earth is a giant magnet. Thanks for joining me in this module. I hope you enjoyed making your compass and learning about all of the science behind it. If you liked this video, my name is Zane. Make sure to tag us on social media using #BeastStemCamp. Make sure to check in next time for another awesome experiment. Beast out!